Hi guys, so I'm gonna go over, you guys pretty much will pick the same ones to go over from the review, so let's do it. Okay, this is number 12, given the graph, identify the following, okay? So the first one is axis of symmetry, and you can just see right here by the graph that your axis of symmetry is gonna go right here where x is 3. So my axis of symmetry would be x equals 3, right? The vertical line right through the center, right? What is my vertex? Right here, it's easy to see that it's positive 3, negative 2, right? How many zeros? 2, right? There's 1 0 here and 1 0 here, right? And it says which are, well, what is it? Right here, 2 0, right? And 4 0. Those are my zeros, right? When x is 2 and when x is 4. And then my domain, you know that it's x such that x belongs, well, you could just write x is all real numbers, right? I told you could just write it like that, right? Or you can even write a big R like that, all real numbers. Okay, and then my range, well, that's your y's, right? So my y is what? It goes from here at negative 2, right? And everything greater. So it would be y such that y is greater or equal to negative 2, right? So even if you just wrote y greater or equal to negative 2, I would accept that. All right, so that is number 12. The next one. We have our function here. This is number 13. Identify the roots. Does it have a min or max, axis of symmetry, y-intercept, all that good stuff, right? So identify the zeros or the roots. You can easily factor this, right? My zeros, right? If this were equal to 0, I could factor this. Factors of 3, that will give you the negative 2 there. So you get x minus 3, x plus 1, right? That works, yes? So what do we have? That means when x is, if I set each piece equal to 0, right, you get a positive 3 and a negative 1, right? Negative 1 and positive 3. So that means right over here, when x is negative 1 and when x is positive 3, those are your zeros, right? Does it have a min or max? A is positive, right? So that means I'm going to be up like this, like a happy face. So that means I'm going to have a minimum point. Right? When I open upward, I have my vertexes at the bottom, right? So that's my minimum value. Okay? What is the axis of symmetry? Well, you can look here and see where the axis of symmetry is going to fall, right? Isn't it going to be right in the middle of these zeros here? Right? So it's going to be over here at x equals 1. But if you didn't realize that from the graph, you could do what? Negative b, right? Over 2a. Negative b over 2 times a is 2 times 1, so it's x equals 1, right? Which, like I said, you can see in this graph that when x is 1, that's right in the middle of my zeros. Okay, and what is my vertex? Well, I know if my axis of symmetry is 1, my vertex is going to be on that axis of symmetry, so it's going to be 1 something, right? So I'm going to go ahead and I'm going to plug a 1 in here, right? A 1 in my function, so that's 1 squared, right? Minus 2 times 1, minus 3, so what does that give you? 1, minus 2, minus 3, so that's 1 minus 5, that's negative 4. So positive 1, 2, 3, 4, negative 4 is down here. That is my vertex. What is my y-intercept? The y-intercept is easy, right? C, whatever C is. So my y-intercept is 3. So that means right over here, 1, 2, 3. That's where we're going to cross the y-axis. Oh, negative 3, sorry. I couldn't see that. I'm like, that doesn't look right. Hold on a minute. Let me erase this because I'm blocking it here. Oh, oops. I am blocking it here, so. Y-intercept is negative 3, excuse me. Negative 3. So that's a good way to check yourself, right? I said positive 3, I'm like, that looks weird, right? So That's why I had to go back and look, right? So negative 3 is right here, and that makes much more sense, right? So you know that your graph is going to go right up like this. It's going to match on this side, right? So that's what your graph's going to be. Okay? And then my domain, again, my domain is all real numbers, right? My range is, this is 1, -4, right? So it's from -4 and everything greater. So y is greater or equal to -4. All right, so that is number 13. What else we got? Okay, number 15. So if a postcard has the dimensions, so here, let's draw a little postcard. Here's a postcard, okay? The dimensions x plus 13, right? So this side is x plus 13 by x inches. This side is x inches, right? And an area, right? So an area of 48 inches squared. Okay, state the quadratic equation that represents this and find the possible values of x, and then find the actual dimensions of the card. So what do we know about area? Area is length times width, right? So that means that x times x plus 13 equals 48, right? Length times width equals your area. All right, so this is an equation that represents that. We want to write it as a quadratic equation. So let's, multiply it out and put it into standard form and see what we can do, right? So that's x squared plus 13x equals 48, right? So I'm going to set it equal to 0, right? I'll put it in standard form. Minus 48 equals 0. All right? And then find the possible values for x. So how can I solve this? I could factor it. Right? I'm going to factor this, right? Factors of 48, that give you a 13. So it's going to be x plus 16, x minus 3, right? This times this gives you that. 16 minus 3 gives you a positive 13. So what does that mean? My zeros are what? X equals -16 and positive 3, right? Those are my two, or positive 3. Those are my two options here. How do I know which one? Well, we're talking about dimensions of a postcard. I can't have a postcard that's -16, units long. We're talking inches here. You can't have a negative when you're talking dimensions. So this one is out, so x is 3. All right? So that means that this side is 3, right? And this side is 3 plus 13, right? Which is 16. So these are my dimensions. Okay? Well, let me know if you have questions about that. What's this one? All right, this one is number 17. Okay? A bottlenose dolphin jumps out of the water, and the path of the dolphin traveled can be modeled by this. So, right? This is a negative a here, right? So the dolphin's going to jump out of the water. Oops. Right? Jump out of the water. We know it's going to be down like a sad face, right? So that's the, trajectory of the dolphin. All right, H represents the height, right? So this is how high the dolphin is. And D, right, your x-axis represents the distance horizontally, right? So if the dolphin starts here and ends up here, he went this far, right? So what do they want to know? A, what is the maximum height the dolphin reaches? So the first thing we need to figure out, whenever you see maximum or minimum, we're talking about the vertex, right? So let's find the vertex, and we're going to find out how high the dolphin jumps, and then part B is how far did the dolphin go horizontally. All right, so let's see. Let's do it you could do a calculator, but let's just do, to find the vertex, let's do negative b over 2a, right? Negative b over 2 times a is negative 2/10, right? All right, so this is actually, if you do the math here, this is 5. Okay? So that means that I'm at 5 something, right? I'm going to find out what the y is, right? So I'm going to plug a 5 in. So it's negative 0.2 times 5 squared plus 2 times times 5. All right, so that actually gives me negative 5 plus 10, which is 5. So that means it's 5, 5, right? So this right here is 5, and this right here is 5. So the maximum height of the dolphin is 5, is it say if it's feet or what? 5. The height of the dolphin, not feet, let's say feet, okay? So 5 feet, okay? So how do I know how far? Well, this is your axis of symmetry, isn't it? So if I go 5 here, I'm going to go 5 here, so that means this is 10. So my dolphin, how far? 10 feet. So 5 feet high and 10 feet horizontally. Okay? Let's see. Number 19, somebody asked me, I think, for number 19, but I'm not going to do every single one of them because it was just all completing the square. So I picked this one. Since it had a greater than 1, I thought maybe we would have to, we should go over that. So find the vertex of the parabola by completing the square. State if the vertex is a maximum or minimum point. Remember, the vertex of the parabola is in the form hk, right? So we're going to complete the square and put it into vertex form, and then we're going to find the vertex, and we're going to state if it's min or maximum point, which you should already know just by looking at this. So remember, we are going to factor out the 2. Plus 17, and remember, we're working on the same side of the equation, so whatever I add, I'm going to subtract, right? Half of 6 is 3, and 3 squared is 9, but remember, I'm really adding a value of 18, 9 times 2, so I'm going to subtract 18. So what does that give me? 2x plus 3 squared. 17 minus 18 is negative 1. So that means my vertex is negative 3, negative 1. And it's at a, this is going to be happy face, right? So it's going to be a minimum point, a minimum value. So that one was, pretty straightforward. And then what else? This is the last one. This video is getting pretty long. It's going to take forever to upload. So let's just get going. The path of a rocket is given by this equation. H is the height in meters, and T is the time in seconds, right? So it's going to go look like this, right? Okay, height, seconds. What is the maximum height of the rocket? So again, we're just going to find our vertex, right? What is the maximum height? And then what time does the rocket reach it? So time is here. So when does this rocket reach the maximum height? So let's do it. We have your x coordinate is going to be negative, or your t, right? Negative b over 2 times a, right? So that's negative 30 over negative 6, which is a positive 5, right? So this is going to be 5 something. Okay, and then we're going to plug a 5 in, so that's negative 3 times 5 squared plus 30 times 5 plus 73. All right, so this is negative 75 plus 150 plus 73, so that's 148. Okay, so what is the maximum height? 148 feet, right? I'm sorry, meters, 148 meters. And at what time? 5 seconds. All right, so let me know if you have any questions. We'll talk tomorrow.